Okay, after 26, 27, now on to question 28, which looks a bit familiar. So, question 28. All right, a cylindrical biscuit tin has a closely fitting lid which overlaps the tin by 1 centimeter as shown. The radii of the tin and lid are both x centimeters. Okay, the tin and the lid are made from thin sheet material of area 80 pi. So area is equal to 80 pi centimeters squared. Tin and lid are made from thin sheet, and there is no wastage. Okay, the volume of the tin is V. Show that the volume is equal to pi over 40 x minus x squared minus x cubed. Okay, so the volume of the tin. Okay then, given the fact that we are looking at that, we need to work out the height of the tin to work out the volume of the tin. Okay, because basically we know that the surface area of this lid, which is whatever it is, x on the radius and 1 centimeter here. We then have another cylinder here, and we don't know what the height is, but again it is x here. Okay, so basically the surface area, the area of the lid, is going to be pi r squared plus we are going to need the circumference, pi times d, times 1 to give us the area of the lid. So that is x squared pi plus 2x pi. Okay, the area of the tin is going to have exactly the same formula, except for the 1 on the end. So we're still going to have an x squared pi for the circular base down here, okay, plus the 2x pi h, okay, so we've got the height of it, and that all equals, when they're added together, equals the 80 pi. So we have 80 pi is equal to x squared pi twice plus 4x pi h plus 1 plus 2x pi h plus 1. Okay, let's get rid of the pi's. Let's make that into 40. So 40 equals x squared. The pi's are gone, the 2 is gone, plus x h plus 1. 2 pi, yes. Okay, so we end up with 40 minus x squared over divided by x minus 1 equals h, which we can simplify out slightly as being 40 over x, minus x minus 1 equals h. Okay, x squared, yes. Right, so we've got the h. Show that the volume, so the volume of this tin is going to be the area of the circle, so 2 pi r squared, 2 pi r squared, so we'll put x squared in, times by the height, which is going to be 40 over x minus 1. Okay, and hopefully this is all going to come out nicely. So let's have a little look at what we've got. Multiplying that out, we'll keep the pi on the outside, multiplying by 2x squared, we're going to get 80x minus 2x squared minus 2x squared minus 2x cubed. Okay, where's the extra 2 snuck in? Because there's no 2 in 2 pi r squared, is there? So let's take that out and make that a 40 and get rid of those. Okay, and we've still got a pi on the outside. Okay, so pi r squared is obviously for the circle, not 2 pi r squared. Okay, that's it. Right then, B. Use differentiation to find the positive value for x for which v is stationary. So let's do dv by dx on that. So dv by dx of all of that is going to be, let's keep the pi outside, and this will be 40 minus 2x minus 3x squared. Okay, and then they want us to find the positive value of x for which v is stationary. So we're going to set that all equal to 0 is equal to, I'm going to divide by the pi to give us 40 minus 2x minus 3x squared, and so I can say x is equal to x is equal to, I'm going to grab a calculator to use the solve function. Okay, so I've got a minus 3 there, I've got a minus 2, and I've got a 40, and we get x is equal to 10 over 3, and we get x is equal to minus 4. So we can disregard that one, and we'll keep the 3 1/3 there. Okay, find the maximum value of v. So if v is equal to this red one up here, then max of v, is this part C? Yeah, proves that this value x gives a maximum value. You didn't find the positive x value. All right, prove that this value of x gives a maximum value of v. So how do we prove that that is maximum? Well, we look at the second differential, and if the second differential is greater than 0, it's a maximum. So we will do, taking that, we will do d2v dx squared is equal to, let's keep the pi outside, the 40 has gone minus 2 minus 6x. Okay, and now when we put in 10 over 3 on it, so now we will do x is equal to 10 over 3, we end up with pi over, no, not pi over, but pi times minus 2 minus 6 times 10 over 3. Okay. What's going on there? 60 over 3. 60 over 3. Minus 20. Gives us minus 22 pi. Why does that not feel like it is greater than 0? Let's have a little look. Have I got that one the right way around when point is local? Yes. Let's have a check. My bad. I've misread the notes in the book. That's for when it's a minimum. It's this way round. When it's less than, it's a maximum, and so therefore that is less than 0, so it's a maximum point. Okay, determine the percentage of the sheet metal used in the lid when V is a maximum. Okay, so the lid is equal to pi x squared plus 2 pi x times 1. Okay, and if we are saying this is the area, if we're saying x is equal to 10 over 3 currently, therefore the area is equal to, let's take the pi out, and let's say 10 over 3 squared plus 20 over 3. Okay, and so we end up with, what does that give us? 10 over 3 squared plus 20 over 3, which is 160 over 9 pi. The total surface area of this thing is 80 pi. We were told that at the beginning. Okay, so if we do 160 over 9 pi divided by 80 pi, we will equal, divided by 80, 2/9, which is 22.2 reoccurring percent. Okay, now on to question 29. So diagram shows an open tank for storing water. The sides ABFE, ABFE are rectangles, and CDEF, okay. The triangular ends ADE are isosceles and right angles. The end ADE and BCE are vertical, and EF is horizontal. Okay, given that AD is x meters, show that the area of triangle ADE is this. So we have basically a trough that is sitting there like that. Okay, and they have labeled it up A, B, C, D, A, B, C, D, E and F at the bottom, E and F. These triangles are 90 degrees isosceles, and the same over here, 90 degrees isosceles, and the ridge line, as you were, is perpendicular to the ends. Okay, and they've told us that AD is X, and they want to show that the area of triangle ADE is equal to a quarter x squared meters squared. Okay, so what do we know about the height of that? So if we've got a triangle which is x like this, 90 degrees, not 90 degrees, but there, equal sides, that one is 90. We need to find the length of that dotted line. Okay, so that's a half x there, that's a half x there. So using Pythagoras, we can work out the length of the side. Okay. Let's have a look then. We can say that x squared is equal to 2. Let's just call these a for the moment. 2a squared, and so it is the x squared divided by 2 square root of is equal to a, and so a is going to be, I've lost how to do Pythagoras, how annoying. Okay, so it's x over the square root of 2, okay, equals a, and then we can use that to work out the sides of those ones. Okay, so we know that that's cut it in half there, so that's a half x. So we've got, let's just double check it all through, a half x. Let's work out what b is here. So we've got x squared over 2 plus is equal to x squared over 4 plus b. So we end up with squared. Half plus is a quarter. Of 4, which is equal to x over 2. Okay, so now that we know that, can we just do x over 2 times a half times by x itself, which gives us x squared over 4 is equal to area. Okay, because we've got the half, the base times the height. Okay, x squared over 4. Good. Also, given that the capacity of the container is 4,000 meters cubed, and the total area of the 2 triangles and 2 rectangular sides of the container is S, show that S. Okay, so let's just look at that for a second. That's what that is. Okay, so we have got that given the capacity of the container, so the volume is equal to that area that we just worked out, which is x squared over 4 times by the length of the entire thing. And so we've got the fact that 4,000 minus x squared over 4 is equal to the length. Okay. We can then work out the area of the trough is going to be area, or S of the trough, is going to be two of those rectangles. So it's going to be x squared over, we'll put it over 4, we'll put the 2 in there, plus the length, which we've just realised is 4,000 minus x squared over 4, multiplied by the length of A, which we had down as x squared over root 2. X squared over root 2. X over root 2 even. Okay, and there's 2 of those. There we are. Alright, so with that in mind, let's see if we can get this looking anything like what they've got in the book. So we're going to have x squared over 2 plus, what's 2 divided by root 2? I feel like that should be something quite obvious. Divided by root 2 is root 2. So we've got root 2x. So we've got 400 root 2x minus root 2x times that is going to be x cubed root 2 over 4. All right. Let's see what we can do with that. This equals s, this equals s. X squared of 4. So this is looking highly messy, but we will continue with it anyway. I am going to take out of here a root 2x quarter. That gives me, there's 1,600 of them in there, minus an x squared. Okay. Okay, so I've lost a 0 there, 4,000. Okay, that gives me up to the 16,000. That's good. All right. Any other mistakes so far? Two lots of them. 2, 6. Okay. Let's see what we can do. Okay, so the reason it's not working is I've tracked my problem down to up here. When you do volume equals x squared over 4 times L, to get L on its own, you don't take it away, you divide by it. Okay, and so if you're dividing by that, that means L equals 16,000 x squared, like that, okay, which is a completely different number to what we have going on in here, okay, which is why it's not working ultimately. Okay, so what does that mean for us here? It means that 16,000x squared should be in this point here. Okay, so let's just add it in, 16,000 over x squared. And now that's probably going to change what we do as we come down here. Most definitely. So let's have a look and see what it has changed into then for us. Take that one out of there. Oops. So no problem making mistakes, it's finding your mistakes once you've made them. Okay, so 2 divided by root 2 again is still root 2, so we end up with 16000 root 2 x over x squared, and that cancels an x there, 16,000 root 2 over x, which I believe is what they're looking for. So you can always find the answer if you keep looking. Use calculus to find the minimum value of s. Okay, so now we are looking to differentiate that. Okay, so that's x to the minus 1 on the end there. So ds by dx is going to be x over 2 divided by the new power of 1. Multiplied by 2, so that cancels there. Getting confused with my integration. X minus 16000 root 2 over x squared. Okay. Use calculus to find the minimum value of s, so we need to take that and say it's all equal to 0 to find the minimums and maximums. So 16000 root 2 over x squared. What to do with that? I think we might... best way to deal with that, if we were to multiply out by x squared, I think that would give us something. So we're going to have 0 equals x cubed minus 16000 root 2. And that means we can say that x cubed is equal to 16000 root 2, and is minus. So we're going to have a minus number. Okay, so that gives us a minus, that gives us a plus, and so the cubed root of that, let's see now, cubed root of 160 is 25 times root 2. Okay, so we are looking for the cubed root of that. So 16,000 times by root 2 there. Cubed root of that is x is equal to 28.284. Okay. Good. So Use calculus to find the minimum value of s. So we've got the value of x. What was a s formula? S formula was, these things go on forever, x squared over 2 plus 16,000 root 2 over x. Okay, and so s is equal to, store that answer as x. Okay, and we can do x squared over 2 plus 16,123 root 2 divided by x. And s is minus 400. Justify that your value of s you have found is a minimum. Minus 400. What's happened there? Because I wrote plus. I wrote minus, not plus, on the calculator. So change that to a plus 1,200. Wrote plus in there, but I didn't put it in on the calculator. So 1,200. Okay, justify that the value of s you have found is a minimum. Okay, so if we have the differential is this, so the differential ds by dx was equal to x minus 16000 root 2x squared, I think it was. Yep. Then the d2s dx squared is equal to 1 plus 16000 root 2 over x cubed. And when we have an x value of 28.28, then d2s dx squared is equal to 1 plus 162 divided by x to the power 3 is equal to 2, which is greater than 0, which makes it a minimum. Okay. Stop there.